And that got me thinking, yeah, you know what? I did want to do, I did want to become an astrophysicist when I grew up. Hi, I'm Joanne Brown. I'm a professor here in the Department of Physics and Astronomy at the University of Calgary.
Nice to meet you, Joanne. I'm Jia Yi, and I just finished my first year of astrophysics undergrad at the University of Calgary.
Awesome. How's it going?
Well, it's pretty challenging, but I'm enjoying it.
You know, it's the same for everybody. First year is always challenging, and transitions are always hard. I know for me, my first year of undergrad was just truly a gong show. I switched my undergrad major 3 times in that first year. So you have to learn all the basic physics, but you get to learn how to apply it in really cool, interesting, fun things. And I don't want to spoil it for you. You'll have to see.
What did you do after your...
Yeah, so after my undergrad, I worked as a geophysicist. And I decided that if I was going to do basically engineering work, then I might as well do a master's in engineering. That allowed me to get a job as a hardware designer where I worked for 2.5 years before I came back to school.
You had this great paying job. Why did you go back?
So I had this idea that I didn't want to be my age that I am now, not having done a PhD. The summer before I started my PhD, I went to my 10-year high school reunion. And at my reunion, I was reminded about the fact that I had always wanted to be an astrologer. And I'm like, no, astronomer, not astrologer. And that got me thinking, yeah, you know what? I did want to become an astrophysicist when I grew up. So after about a month of being in the electrical engineering program here, I switched into astrophysics. And yeah, it makes me seem a little fickle every degree. I switched a couple times until I got it right. And eventually I did graduate with my PhD in astrophysics.
So what's the difference between like PhD and master's?
Okay, so I would say a bachelor's is all about learning the foundational pieces. And then when you go to do a master's, you have somebody guiding you, but you're actually doing a little bit more research, like on your own, to contribute to the body of knowledge so that you're not just learning what other people already know. For a PhD, it's a lot more independent research, significantly more independent than a master's project. So
what if you just never figure out anything significant?
You know, anytime you put effort into something, you will learn something.
It's good to hear. So what kind of work do you do?
So I study the magnetic field of our galaxy.
Oh, the Milky Way?
That's correct. So our Earth has a magnetic field. We kind of know that. That's the way compass works. So the sun also has a magnetic field.
Really?
Yes. And that magnetic field actually encapsulates our solar system and protects the solar system as it moves through the galaxy. So all the stars and all the solar systems are moving throughout our galaxy. And so there's sort of a wind that blows by, and that the magnetic field from the sun protects our whole solar system. So we have the Earth's magnetic field, we have the sun's magnetic field protecting the solar system, and then we have the galaxy that has a magnetic field. And that magnetic field threads everywhere between the stars. So we call it the stuff between the stars, otherwise known as the interstellar medium. So there's 4 things that make up the interstellar medium. One is gas, one is dust, cosmic rays, and finally magnetic fields. The thing about gas, dust, and cosmic rays is they all give off some sort of light. Magnetic fields do not give off light, so we can't see them directly. But we can see them indirectly because magnetic fields affect light. You know, we can sort of get some sense about whether the magnetic field is coming towards us or going away from us in different lines of sight. And that put it all together and we get this sort of image. And if we could look from the North Galactic Pole down onto our galaxy, what we would see is the magnetic field is going clockwise everywhere, except one region that spirals out counterclockwise. And we don't see that in other galaxies. So it's a little odd. All of my effort has been focused on trying to identify what the magnetic field looks like now, which will put proper, constraints on any modeling that's done to sort of, predict how the magnetic field was originally formed. In the Earth, for example, we believe that the magnetic field is created by what's called a dynamo, which takes the motion of the conducting fluid that's inside of the Earth and produces currents, and those currents then produce a magnetic field. And so the same idea, we believe, is what's happening in our galaxy, that there's motion of conducting fluid, which is the gas between the stars, and that produces a current, and then from those currents we get a magnetic field. The question is, what kind of currents, where are the currents located, how are they flowing to create the field that we observe. And when we look at the magnetic field of the galaxy, we see that we have the magnetic field going one way on one side, one spiral arm, and the other way in another spiral arm. That would imply that there's a current sheet perpendicular to the disk of the galaxy, which doesn't really make sense on a sort of a warm fuzzy level.
Yeah.
So I think that this image that I created with over 20 years is actually wrong based on the data. Science, this is the way science works, that we get more data, we learn more, and we start to realize that we need to learn more as well. So I think what might be happening is something similar to what happens in our own solar system. So we have the sun that has a magnetic field. It's a dipolar field, right? So it comes out and then back in. Yeah. And then there's a solar wind that's blowing it out, and it sort of pulls it out and goes around the planets. In addition to that, the spin axis is offset from the magnetic axis. And so what that does is you get sort of a ballerina skirt happening to the magnetic field of the sun as it blows away from the sun.
So it's like making noodles.
Yeah, well, it's sort of going up and down, right? And so what happens is that when planets are underneath of the ballerina skirt, it sees the magnetic field going towards the sun. When planets are above the ballerina skirt, it sees the magnetic field coming away from the sun. And so you sort of see this reversal, right? Depending on whether or not you're above or below the ballerina skirt. Yeah. And so I think something like this is what's happening in our own galaxy, that this reversal that we're seeing isn't actually a reversal this way, that it's actually somehow we're seeing above and below a similar effect in our galaxy. But that's going to require a lot more data and a lot more research.
Yeah, is that your next step then?
That's what I'm working towards, is trying to understand that, yes.
Wow. It's impressive how much, we're just a tiny planet in this whole universe.
Yeah, that's one thing, that is one thing that is really humbling about working in astrophysics, is you realize just how big the universe is. It actually hurts my brain to think about it, and how lucky we are to live on this planet.